right, y'all. We are looking at 2.7, creating functions from functions. We're going to put the fun back into function, be doing some number crunching. It's going to be great. So, we've created functions before. We've done it based on relationships to two variables. That's what this paragraph says. Please read these. You have a packet. Read it, learn it, love it. Okay? But what I want to talk about today is composition of functions. So we're going to take a function, we're going to plug it, or a variable, plug into one function, and then plug in the function to another function. It's functionception. Where's Hans Zimmer when I need him? If you're having brain fog, so is this equation. Now, something that's important to realize, the domain of your composition has to be that the domain of your g of x is in the domain of f. The domains have to match. We'll see. You'll see. Sorry, that was quick. Just so you guys know, in YouTube world, this is my most watched video still in my original pre-calc curriculum. So it's obviously great. Yeah, because people said this is too easy. I'm going to keep rewatching it. This night's shirt was from Rate Rick.
What's rate?
All right. So I got great news and I got even better news. The first thing is I need to find my page. This circle symbol means composite. So, again, you've probably seen this before. That's f, well, I write of. F of g of x is the same thing of f of g of x. These mean the same thing. Okay? Oh, I should put that in parentheses. Oh, it says it right here. F of g of x. Okay? Now be careful. This is different, not equal to g of f of x. Okay? Based on our order of operations, if I see something like this, what would you do first? You do your g of x, and whatever you get for an answer, you plug into f of x. Order of operations. This one you do f of x first, and then plug it in for g of x. Phew. Kind of ring a bell? I should have a bell back here and make really bad puns. Like, does that ring a bell? And be like, I used to have a drum kit on my desk, actually. It broke. And I go, yeah. All right. Let's find f of g of x. And then we're going to find g of f of x and see if they're the same. Okay? Move this out of my way. So over here, I'm going to do f of g of x. What's my g of x?
4 minus x.
4 minus x. So I'm going to plug in my g of x in for g of x. Any questions what I did here? I just substitute in. Bless you. Now, wherever I see an x, what do I need to plug in to my f of x? The 4 minus x. So I'm going to do 3 times my 4 minus x, which, just a reminder, that was my g of x, right? Minus 5. Am I done? Technically, yes. But we'll make it, we'll simplify it, right? We'll distribute. Yeah. What's 12 minus 5?
7.
Yay! All right, anything too scary yet?
So,
What do you mean? Like negative 3x plus 8, 7? Yep.
3 4 minus x minus 5 and 7 minus 3x. What goes down and 2?
Like this?
Like the third.
Like these are both the same thing?
Yeah.
Yeah, but simplify it because sometimes we want to compare it to another function. It's easier to compare. You can't compare things unless they're fully simplified. All right, now let's do our g of f of x. All right. What do I plug in for my f of x? Yeah, so I'm going to plug in 3x minus 5. Now I'm going to take this and plug it in wherever I see an x, correct? So I'm going to do 4 minus 3x minus 5. Make sure when you're plugging in for a function for a function, put it in parentheses, right? If you don't put in parentheses, you're going to have a bad time. Okay? What's up?
How did you get, like, I get the g of 3x minus 5, but then I don't get the 4 minus 3x minus 5.
Do you see how this is 4 minus x, right?
Yeah.
So wherever I see that x, I'm substituting that equation in. Because it's g.
So with the original, right?
Do you see how this is g of x? So I plug in an x. Now it's g of 3x minus 5. So I plug in 3x minus 5. Whatever's in here, I plug in for my variable. Am I done with this one yet? No, we got to distribute and simplify. Wait a second. Oh, yeah. Wait a second. These aren't the same thing. But they're not supposed to be because these are different things, right?
Yeah.
Phew, I was really scared there for a second.
Yeah.
So, wait. The question is it commutative? What's it mean to be commutative? Same either way. So, is it commutative? No! You asinine fool.
Oh.
Hey,
I was,
give me saying something around the back of my shirt.
Yeah.
oh, that's true. Oh, that's going to be awkward. Look at this narcissist.
That's one of the next year.
Oh yeah, you're gonna be listening.
I'll only wear it here. I should put googly eyes on the eyes, so I turn around, there's like, my face is like bouncing around. Bedazzle it. Yeah, I took a picture and sent it to her. She can wear it.
Yeah.
That's true. Alright. Uh-oh, Mr. Twilliger. That looks different. That's the same thing as what? F of g of x, right? Okay. What's my g of x? 1 over x plus 2. Right? I'm just grabbing my g of x. Now, this one's a little bit different, right? I have 2 x's, and they all live in Texas. So what do I have to? I have to plug this in anytime there's an x, right? So this is going to become 1 over x plus 2 squared minus 3 times 1 over x plus 2.
Alleged.
Like, okay. You are right, Mr. Olive Green Sweatshirt. Things are going to get a little bit dicier here. All right, what's this become if I want to simplify it? What's 1 squared? What's x plus 2 squared? Let's just make x plus 2 squared. Trust me, there's a reason. What's this become? 3 over x plus 2, right?
What you're saying is precisely.
I'm still not simplified yet. But actually, you know what? This is good. This is fine. This is fine. What's my domain? What can't I plug in for x? Can I plug in anything else? Yeah, because it's just 1 over x is everything except your asymptote, right? So what's my one number I can't plug in? So I go from negative infinity to negative 2. I can't equal negative 2. And then negative 2 to infinity. Remember, that's a jump. We're jumping over the asymptote.
Okay.
Now, you guys want to know something wild? Wasn't my domain already restricted by g of x?
Oh, yeah.
Same restriction, isn't it?
Yeah.
What? I can't hear you at all. I'm old.
It's just quiet.
Multiply x plus 2 times 3, and then multiply it by the denominator by.
Oh, and combine them? Yeah, that's if you really wanted to simplify this, you would have done this. You know what I mean? And then that becomes x plus 2 squared. And then this would become what? 3x plus 6. And 1 minus that, right, would be negative 3x minus 5 over x plus 2 squared. That's the simplified form. Yep. But same restricted domain, correct? Great album.
What is it?
Never mind. Nirvana. This is the one with Smells Like Teen Spirit.
I don't honestly.
No, Drake. Come at me, Drake, but you might be overrated. All right. What's he going to come in down from Canada on his moose? All right, so here we go. I'll rap battle you, Drake. I will do it.
Why did we get that?
Yeah.
All my 40 views. All right. What's my f of x? Okay. Now I'm plugging that in for my x on my g, right? Any questions? Because this was here. I'll put that in parentheses so you know I plugged that in for x, right? But for this one, the parentheses are going to go right away because it's just addition. Do y'all agree on that? Okay. That wasn't too bad. Nothing to simplify. Uh-oh, but what about my domain? This is a nice review from Unit 1, actually. What do I do to my bottom? I got to factor it, right? So that becomes what? X minus 2, x minus 1, right? So what two numbers can't I plug in? 1 and 2. So I would go from negative infinity to 1, 1, 2, 2, 2 to infinity. Because we're jumping over the, I can't jump. I'm not allowed to yet. It's true, actually. I'm not allowed to yet. You know, back in my day, or if you take other classes, technically you could say all real numbers, but x can't equal 1 or 2. Is the same thing. No, they want interval notation. It's more useful, actually. If you're doing computer programming and you want to set values for something to exist, you use interval notation. That means nothing. Or Minitab or stuff. This is more important than that. All right. There's no way I'm getting through examples 1 through 6.
Yeah,
No.
yeah, let's just not do anything like 3.
No, these are, no, absolutely not. Yeah, just use your calculator. Uh-oh. All right, what's this one? Oopsie. All right. What's my h of x? I lost my picture. Root x. My root. On C. Can't you see? All right. What was my f of x? So now I'm going to plug in square root of x squared minus 3 times square root of x. Is that kind of making sense? Or at least that part, like how I'm plugging stuff? I got great news on this one. What's square root of x squared? X. And this is just 3, negative 3 root x. Okay. Domain. This, I can plug in anything to x, right? What can't I take the square root of? Negative. Can I square root 0? Yeah. So my domain on this one's going to be 0 with a bracket to infinity. A bracket because I can plug in 0. So this is, again, a review from Unit 1. That's why I'm taking more time. I want to make sure we get domain range. That'll come up. You can't be 0 on the bottom. You can be a 0 in your square root. Can't divide by 0, but you can square root 0. Ooh! I'm sorry about D, but it's a good review from Unit 1 as well. I'm not sorry. If I was sorry, I wouldn't do it anymore. Dude, that drives me crazy. You know what? Internet, you need to hear this too. If you apologize for something and continue to do the same thing, it means your apology means nothing. All right. Quote of the day. Yeah. All right, so I'm doing h of x squared minus 3x. Agreed?
Yes.
So h is just square root function. So that's going to be square root of my x squared minus 3x. Do I need to put that in parentheses? No, that's implied parentheses, but I'm just showing you why I plugged it in. So that part, not so bad, right?
Yeah.
What about that domain? Domain on the range, where the deer and the antelope play. What do I do? Yeah, what I'm going to do is, what can't this be? So I want to know, when is x squared minus 3x less than 0? Do you guys remember how to solve that from Unit 1? I'm going to factor it, right? Do y'all agree on that? Do you guys remember this thing? When is this less than 0? I got good news so far. Do you want to do it even easier? What's x squared look like? So where's it going to be negative? Between 0 and 3. Does that make sense? Do you have to wiggle graph this? No, it's a parabola that opens down. So I know where it's going to be negative because it hits 0 here and here, right? So it's going to be negative between 0 and 3. If I didn't see that, you have to plug in points to your graph, right? And you get positive, negative, positive. But it's a parabola that opens up. So what can't I plug in? I can't plug in any numbers between 0 and 3. Can I plug in 0? Yeah, because it's a square root of 0. Can I plug in 3? Yeah, but I can't plug in 2. So I'm going to go from negative infinity to 0. I'm going to go from negative 3 to infinity. I'm at 3. That trip knocked some sense in me. If I fell, would you guys help me? What if I dropped a bunch of Hershey Kisses on the ground after? If you'd like to learn more, take AP Stats. I felt like, have you ever played Sonic and you get hit and you drop a bunch of rings? That's what happened in AP Stats.
Somebody fell and so and then he tried to play it off.
No, it was...
Everyone else was silent and Reagan was like dying. Miguel found that shit like 75 times. No, Miguel only did that when you were.
Not gonna make it. I'm trying really hard though. All right. hey, graphs! You guys are excited now. So I'm doing f of g of 3, correct? So the first, which one's f of x and g? This is my g of x, correct? So the first thing I need to find is what's g of 3. So I go to 3. G of 3 is what's my y value? 1. So g of 3 goes to 1.
Okay, that's
Right?
Oh, yeah.
And then f of 1 is 2.
Oh,
Nice and easy, and then we go to like Mexico.
yeah.
That one was easy.
Yeah, let me easy.
Oh, there's the.
What? Oh, I will. 5 more times. I'll do better this. Here, I need different color. Where are all my markers?
Some in that.
Watch this.
Yeah.
I know what I'm going to do. So I'm doing f of g of 1. It's written right here, right? So what's g of 1?
3.
So I go down here and I plug in 1. And what's my y value? 3. Do y'all see that? So now I got to do f of 3. So I go up here, and what's f of 3? 2. This is kind of like, honestly, they do a lot of stuff like this in escape rooms and stuff. You just don't realize it. Like, you have to plug in one thing to something to get the other one, like coordinates and stuff. Has anyone ever done an escape room? Highly recommend. I love escape rooms. They're a blast. If you like escape rooms, they also do, they're getting more and more common around here. There's like trivia nights at like bars. And I think Rotary Club just did a trivia. And the trivia is not just like straight facts. There's like puzzles and stuff now to them. They're a lot of fun. Highly recommend. We tried to make one at a lock-in one time. That'd been cool, actually. But they're a lot of work. All right, let's do this one. This one's easy. You want proof? It's not bad. Let's take it piece by piece. What's g of 4?
0.
Like my bank account. What's f of 0? 4. So this piece is just 4, right? And then I'm going to times it by whatever I get over there. See, it's not bad.
It just looks really hard.
What's f of 1? Oh, Jiminy Crickets. What's f of 1? 2. What's g of 2? And 4 times 2 is? 8. Huh? Test today. Test. I'm going to skip. Wait. I'm going to do deep. I'm not going to do E and F. We don't need to.
Yeah, we got it.
Why do they go back to like this?
That makes me happy.
Or I wondered if they went outside. Oh. No, they don't. Never mind. You're fine. Do both these domains match? Yeah, so there will be no wonkiness. If some of the domains don't match, there can be wonkiness. All right, what's f of negative 1? 6. So it's 6 over, what's g of 3? 1. And what's f of 1? 2. That's, I didn't even need my answer key. What time is it?
It's 2:50. How about you just keep us here because we're all going to tech center?
Are we? Everybody?
I don't leave till like 11.
We don't need much.
Let's just AP Pre-Calc. I'll have to lock in AP Pre-Calc.
Okay. I didn't tell us what to do.
Yeah.
I definitely don't have time to go over this. Jimmy.